All right, sorry about that. If you were watching earlier, I had to go clean up some stuff. Okay, so I'm back, and let's get some music going, and let's get back into building a physics engine. Because there's nothing more fun than physics. All right, so before I abruptly left, I was trying to figure out in physics what they call D. Common physics notation, distance, or direction. I believe it's direction. So here's what we're going to do. Whoa. All right, so we're going to call this direction. And we're going to create a new vector. Right? And this is going to be very similar to our move logic. Basically, what we're going to do is we're going to apply a direction. We're going to apply gravity to a direction if there's a force on that direction. So I might need to, let's leave it like this so it's as clear. It's a lot to type out. We'll call it DIR for direction. All right, the other thing that we need on the entity is entity dot is, we're going to call it standing equals false. Entity jump velocity is going to be equal to jump velocity or 3. And I think that's all we really need in order to configure a physics entity. So let's go and find our player, and what we're going to do is we're going to remove the move entity logic, and we're going to instead configure the physics entity. We're going to pass in entity, and we'll leave the jump velocity at 3 just as it is. If you're just tuning in, I'm trying to write a very quick physics engine. I basically have like an hour and a half. So I'm trying to see if I can take the old physics engine and sort of adapt it to work a little bit better here. So now we removed move entity. We're going to use physics instead. And if we come in and we run the code, nothing's going to happen. But more importantly, he's not moving. So we're going to do some basic stuff here. What we're going to do is take, we're always going to apply gravity, right? So accumulate gravity between each update. So let's go in here, and on update, we're going to call, we're going to apply our button logic here, right? So this is input actions. And then here, we're going to apply physics. And we're going to pass in the entity and the time delta. So we're not doing anything right now. What we're going to want to do, and we'll take a look at our basic entity class. We have some logic here where we simply calculate the delay, which is the delay between the frames. We should actually call this delta. We'll leave it at delay for right now. And we're going to do something very similar here. In fact, I'm just going to copy this whole thing. And let's just paste this over here into the physics. I'm going to take the direction Y. We'll do the rect Y. And what I actually want to do is we're going to start by taking the test position. So first off, we're going to get the current entity position. So test position X is going to equal entity rect X. Test position Y is going to equal the entity rect.y, right? And then we need to figure out the delay between each frame. So in this case, it's going to be 100. And we're going to apply to the test y value. We're going to set test y equal to test y. And then if we looked here, what we were taking was the entity direction and then gravity times delta. So here, we're going to take gravity. We're going to set gravity equal to 1. So basically, the player or any entity will fall 1 pixel per frame. And we're going to take the gravity. We're going to take the, let's do this. We don't need the absolute value. What we want is entity direction y multiplied by the delay multiplied by gravity. So the delay should be like 1 or 2 based on like how much the frame rate is fluctuating, right? So that'll be how much gravity is added. So let's just test this out for a second. And the last thing we're going to do for testing is we're going to take the entity y position and set it equal to test position y. Let's just see. This should make the player fall. Entity rect.y. All right. Print. I hate math. All right, so let's set to 0. Let's figure out what's going on here. We want the delay and gravity. The entity's direction doesn't really matter right now. So that's 1, 1. So what we should do is, the direction is 0. It should be plus. So we're going to increase this based on whoops, hold on, let me get this out of here. What we're going to do is we're going to take the test position y and we're going to the direction y plus the gravity and time delay. So delay multiplied by gravity plus the direction. So this should accumulate gravity over a certain amount of frames. All right, let's put the player higher up. We'll watch him fall. He should accumulate so right now that's wonder why it's going so slow. Oh, I see why. The dy should be, all right, I see what we're doing. What we're going to do is we're going to take the we're going to increase the direction y by gravity over every frame. Right? And then we don't add this should be entity, look for a solid tile, entity y, math, entity y plus. All right, so what we're going to do is take the test position plus the direction y. So over every frame, direction y is going to go, oh, hey guys. Welcome to the stream. I'm sort of in a rush this morning, so there we go. All right, so he fell pretty fast. What we want to make sure is that entity direction y if direction y is greater than 5, then and set this to entity direction y equals 5. All right, so it's going to happen pretty fast because it's just the nature of the beast. So what we want to do is let's start testing to see if we're moving down or not. So if entity dy, so what we're going to do is, so if entity direction dot y is less than 0, right, or greater than 0, all right, check when the player is falling. So what we want to do is this. We're going to take the test position all right, let's pull this and this out here. And we're not going to make him fall right now. We're going to apply this later. So now he shouldn't fall anymore. 43, if entity direction y is greater than 0, meaning that he's falling. Right now he's just going to stay where he is. What we want to do is check that we're going to figure out the x and y position to test for. Now we're going to leave, so here's what, here's some things that we're going to have to do. This is where I feel like I was failing before in the physics engine, is that this all made a lot more sense when Matthew wrote his little like platform stuff and it was all for an 8x8 tile. What I want to do is come up with a cleaner way of testing the edges of our player. So we're going to start with the y position, and all we need to do is take the entity rect plus the entity dot rect dot height, and let's do calculate the bottom of the player. Right, and then this is going to be calculate the left, or calculate the front of the entity. So, all right, it's going to be a little bit different, right? When an entity is moving to the right, what we want to do is figure out local direction facing equals entity dot flip h, and if it's set to true, it's going to be -1 or 1, right? And what we're going to do is take the if facing is true, actually we can do it all right here. If entity flip h is true, we're going to get the rect's left position, or we are going to get the we're going to get the entity dot rect x plus entity dot rect plus width, which would be the right hand side. So calculate the front of the entity based on the flip h value. Now calculate the bottom of the entity. Here it doesn't really matter where we test. And this is, so there's two things here that we got to figure out. One, we're trying to, all right, we'll deal with that stuff later. There's some subtlety to this that we might want to basically test for. But what we want to do now is we're going to take, so basically we look for the flag. So there's something I wanted to do here. Let me, we're working on our physics here. So one thing that we want to do is decide if we need to, if the player is out of bounds. And that should actually be handled by the map generator. The code collision should now test to see if the entity, not collision, sorry, the entity manager is going to test that the player is within the boundaries of the screen. So what I want to make sure that's happening is this. Let's come in here and we're going to call print update player, right? So if we were to come here and redo this, you'll see that it's calling update player constantly, right? Now let's come back in here. Let's add our physics. And what we're going to do is for collision and do test. We'll assume that there's no collision, and we'll do test position Y. Actually, what we'll do is apply movement. Entity rect Y equals test position Y. And what we should do is I want to do something here. Local previous position equals new vector. I don't know. Well, this is going to break stuff, which is the problem here. But let's just say this is. Well, let's just test this out right now. What we're looking to see is that the player falls to the screen. Whoops, that didn't work. Entity rect Y equals. Direction Y plus direction Y. Plus direction Y. All right. So let me try this one more time. What we're looking to see is that the player updates and then it stops running. Right? So now the player has been removed from the screen. In fact, what we can do is... where the hell did I put my snake? We can copy the on remove over to the player. And this should spawn the explosion. Let's see if he explodes when he goes off the bottom of the screen. Well, you probably can't see the explosion. But here it calls create explosion and the player is dead. So in this case, you can't really see that the player exploded, but it did. And it stopped calling this update. So the beginning of our physics is good. What we want to do now is, this is just too hacky, but let's do this. We want to test for the next, we're going to test for where the player is going to move next. And in this case, we're just going to look for, flag. All right, so let's look for a flag. So we're going to get this flag repeat. We don't need to do the repeat stuff. We'll just do test position X divided by 8, divided by 8, and we're going to do math floor. And let's see, so print, and we'll just do flag. Yeah, we'll just call flag. So here we're just going to see if we hit a flag. And what we're going to do is if flag does not equal -1, then we'll apply, we're just going to apply this value. There's going to be there's a lot cleaner way to do this. Right now I'm just trying to like validate a few ideas. But what was it printing out? -1. If flag doesn't equal 0. All right, let's try this now. There we go. So the player fell and he hit 1. Now what's happening is that the player is falling below the ground because we're testing out the collision below the player. So like what we should do is what we want to do is we really want to test. So I'm trying to figure out the best way to test out where the collision is before we hit the ground. So let's just do this. Let's just say we test for the entity's rect Y and rerun this and see what happens. Oh, wait, we need to do entity rect height. All right, let's get rid of the rect height for a second here. So what we're going to do is we're going to apply the direction Y to its Y position. And it fell in the same place. All right, so I just want to see if seal does anything. All right, so seal brought it up 1 position. I just want to take a look real quick at where this guy is. If you're just tuning in, I'm just trying to build a very basic physics engine. I have about an hour and 30 minutes left before I have to really stop. And, all right, so here's what we're seeing. This is the top left position of the player, and what's just making it hard to figure out is like where he's actually colliding. And this is sort of what I need to figure out a good way to debug is. Now, can I do? Let's see. It's my game engine, but I can't even remember if I could do this. Let's draw rect 10 10 draw rect 10 10 8 8. We'll do this as color 1, and I want to draw this draw mode tile map cache. All right. All right, here's what we're going to do. See that box right there? We're going to use that box to test out where the player collision flag actually is. So let's make this 4 by 4. Or actually, we're going to make its width 4 by 4. I don't know. We'll take... Well, we'll do this. Let's start this. Let's do the test position X plus the test position Y. And we'll leave it at 4 by 4. So now, when it falls, you could see it hit the bottom of the... It's hitting the top of the tile. That actually came out pretty cool. It hit the top of the collision, the ground, but our player isn't at the right height. So let's take a look at our player real quick here, and let's just see where we set its height. Because I don't think our player's height is really set. And so where's our physics entity? All right, so I think we need to set a width and a height. And we just need to make sure that the physics entity has this thing. So entity dot rect dot x, or width equals width or 8. We'll make it 8 by 8 if it's just by default. Rect height or 8. But there's nowhere where I'm setting its width and height. So we're going to set the configure the physics entity, and we're going to set its width to 3, 16, 24, and its height is 32. Let's see here. 24. Let me see here. Where is... let's open up the graphics and take a look real quick. We're in Sandbox in the right workspace. We'll open up our sprites. All right, so our physics engine is 24 by 24. All right, so that'll set the width and the height. And now if we rerun this, you'll see that it's now, the square has been aligned to the right because he's facing right. And it's at the edge of our gun. Now, if we were to take the player and set him to false and rerun it, you'll see that the square, whoops, really? Spawn entity. Why does spawning the player not change his direction? On remove. That's interesting. I wonder why this should make, let's say it's true. All right, there we go. It flipped the player. All right, so what we're seeing is we're now getting, we're now seeing that that box represents where we're actually testing for the collision. So now let's do this. We're going to set this to 1 by 1. And let's rerun this. And it's going to be hard to see. We're going to do 2 Rex. This is... Now let's see if we can make this like a little... There we go. All right, so we're trying to get this to be exactly at the position where In fact, actually, we went back to 2 and 2. All right, close enough. So what we're trying to do is just find the actual position of where we're testing. So at least we got the width correct. So one of the things we want to do here is I feel like we want to also set an offset X, offset Y. Rect offset equals new vector offset X or 0. Actually, I think by default offset Y. All right, so why are we doing this? What we're going to look for is that, well, actually what we should do is we should set a collision and use the collision and not the... Yeah, let's stop rebuilding stuff. Let's do this. Let's get rid of this width and height. And we're going to use a collision. In order for this to work, the player is going to have to create a collision area. So let's do this. Configure animation. Configure collision. So, all right. We're going to do two things. We're going to call this player, which will set a collision area on it. And if I remember correctly from the collision, when we look at setting our collision, we should have a width and a height and an offset. So here we're going to set it to 24 by 24, but let's come in here and look at our player. Really, his collision should be 5. It's going to be somewhere around like, yeah, 5 by 5 should be fine, right? So if we were to come into here, five by 5, let's just set it to that. So 5 by 5. All right, what I want to do first is we're going to come back into our physics engine, and actually let's go into our collision area. Let's set a debug collision. And we're going to add a little thing that's going to draw a box around this. Now, what's kind of weird is that it's not... Why is it not... I want to test something out. I have to... It's kind of weird why this wasn't draw rect. Oh, I have this drawing the tile map cache. What I actually want this to draw to is the UI layer. I'm just going to try to see if I can do some like basic drawing stuff here to help us debug. Entities, code entities, line 40. All right, so now that's drawing cleanly. So what we're going to do is I'm going to have to do some I have to add some stuff. Like generally I should be able to do some canvas stuff here, but I wonder. I'm just trying to think if I want to, how I want to debug this. We can do something like this. Like let's just do some basic stuff right here. So if debug collision is true, here's what I'm going to do. I'm going to add, for right now, I'm going to add 2 colors to this. Let's actually do it here. We're going to do add collision debug color. So what we'll do is color ID 4 is going to equal FF0000, right? And on update, test collision, new rect, when we test a collision, we're basically going to look for target A. Well, actually, we'll do 2 here. For 5. What we're going to do is we're going to draw a box around each of the collision objects just to see. So here we're going to do draw rect target A rect. Well, actually, it should be hit rect X. Height, and the color is going to be 4, and the draw mode is going to equal UI. Let's just see real quick here. I think this only works when we do a collision. All right, so you can see it's drawing a red box around the actual object. What we need to do is take the target X rect dot X plus, actually we can just do it here. Well, here we'll calculate this stuff. And we'll make this, we'll have it draw a box around the area. Draw right. So what I'm trying to leverage is that if you don't have a collision area around the object, the physics engine won't work, which sort of mirrors a lot of other physics engines. The only thing we hear, target A intersects with temp rect, would be target B. So that's 4, 5. So you're seeing it's basically drawing its own targeting, its own rectangles to see where the rect is. Now look, if you look at the player, what you're seeing is that the player isn't, well, I mean, this is just a hacky sort of way of doing it. But right now, the rect for the player, let me fix this for a second here. Oh, interesting that the rect is coming back around. All right, so what you're seeing is that the player's collision area is higher than it really should be right now. I don't know if that's because of the physics, taking into account the physics, the falling. Let me remove the physics for the player for a second, and get rid of update physics, and we'll put the player here. All right, so what we got to get is this rect to be right at the player's position. Negative. Why is the player so... The collision area should be 20 high. Should be 20 high. I'm going to fix this in a second. Like what we want is something like this. We want its, we want its collision to be right in the center of the object. So it's going to be something like the width is going to be 14, 21, 14. And what I'm going to do is we're going to add a function debug collision entity and end. And what we'll do is whenever we choose to when we choose to draw this, we don't need this. We'll just do something like this. Let's come here and get all this out of here. Put this here. Put this back into here. And we're going to manually call the temp rect stuff when we need to. So this will just be entity rect x. All right, so debug collision. Let's get our player here. When we update our player, we're going to debug collision and pass in the entity. And this will just draw a box on top of our player or it'll break. Code collision line 5. If entity.hitRect equals nil, then n return. All right, so line 11, it doesn't like this idea. Line 11, temp rect. Oh, here we go. I think that's because temp rect is down here. So let's put that up here. So now we're seeing this is the basic rectangle for the player's collision, right? And this is what we want to be using whenever we go to test. So if we come in here and we do the physics engine stuff, I wonder if I can make this sprite above. There's a few different layers in Pixel Vision 8 that we can render to. Bar? Collision. Does that render correctly? All right, so here you're not going to see it because I'm rendering it into the background as a sprite. If we were to change the player to... Well, there's a few things. What I really need to do is get the canvas working a little bit better so you can draw some debug code, but I'll deal with that another time. So now what I want to do is when the player's physics are involved, what we want to do is if entity hit rect equals nil, then n return. Only works if entity has a hit rect, right? And what we want to do is we need to find the test position of the player based on its collision. Now, let's go here and let's go back to updating the physics. And what we can see is the player, there's a little dot. You can't, it's really hard to see. I'm gonna do this. Let's do local debug. Well, we'll just do this. Color 5 equals pound 00FF00. We'll make this color 5, and we'll do this as sprite above. So see that green, that really bright green dot is where we're actually testing for the player's collision. Now let's fix this, because what we want to do is this is really going to be the hit rect.width. So let's move that over. Plus entity hit rect x. So we're going to be testing for the boundary of, oh, you know what we could do? I could shift the square that we're in, but let's do this. All right, so right now we're testing at the far right edge of the player's collision rectangle, right? And now if we came in, and now the next thing we want to do is now look at entity y plus direction y we need to get the rect y. All right, so there's the hit rect y plus rect height. Hit rect height. There we go. So now what we're seeing is that the player is at the bottom of the screen. Now, what I'm kind of confused about is let's take a look at where it's actually testing. And we'll do this as X, Y, and we're going to print out print Y. I got to clear this log file because it's probably just like gigantic by now. All right, so if let's get this here and let's run this. So what we're looking at is 718. 1, 2, 3, 4, 5, 6, 7. Actually, we can do the testing here. Let's test out the screenshot and just see where the position is. Because this should now be 1, 2, 3, 4, 5, 6, 7. So we're within, we're at column 7. And we're at row 1, 2, 3, 4, 5, 6, 7, 8. 18. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so I think he moved too fast. Let's do this. I want to make sure that the player is only moving Interesting. Now he moves faster. 7. Why is... What is entity direction Y? Delay plus gravity. If gravity is set to 1 and the delay is set to 0, two. So right, every frame he should move down 1, and his velocity right now is 2. Entity direction Y. I feel like this is really velocity. I don't think this is direction. Why is this not working? What am I missing here? Somewhere I'm adding too much to this. The entity's rect Y plus the direction Y. Clearly where my math skills taper off. Why is this direction Y? All right, let's see what the direction Y is and make sure that when we're adding it, it makes sense. So direction Y is only 1. Right? So what I want to figure out is, so direction Y, so the next thing I want to do is entity rect Y, and then entity rect Y plus this direction. Would move the Y position. right? So we're only moving 1 frame a second. So we're going from 24 to 25, 41 to 41, 24, 40, 56, 72, 88, 104, 120, 136, and then it ends at 136. Now, calculator, 136 divided by 8 is column 17. So if I'm here in Photoshop and I look, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14. When it hits 14, it shouldn't. So what I'm trying to figure out is the gap here, right? Let's take a look. If we have 40 minus 24, that's 16. So it's moving, he's moving 16 frames, 16 pixels in that 1 frame. 40 minus 56, oh, sorry, 56 minus 40 is 6 frames. 72 minus 56 is 16 frames. 88 minus 72 is 16 frames, or 16 pixels. 104 minus 88. Sorry. So he's moving twice. He's moving at 16 pixels high. I think the problem that's happening here is, I think I know where the issue is. When I'm setting this back, I'm setting it to the test position. What it really needs to be is this right here. So I'm moving it by the whole size of the. So let's see. Whoops. Let's move it just by its actual change in position. There we go. Boom. All right. Because now we don't want the gravity to ever be greater than 5. And we can set gravity to something like 3, and it'll ramp up a little bit faster. There we go. That was the problem. So now what I wanted to test real quick is if I remove all of this stuff here where I'm getting the position based on the height, now it should drop it to the top of the player. Perfect. There we go. So we've solved this now. So now we have physics. So now he hits the ground. What we're trying to avoid is if he's moving so fast that he moves through the floor, you wind up with a problem where we have to actually calculate the gap in pixels between the last frame and the current frame to make sure we didn't hit anything solid. I'm not going to do that check, but the next step of what we would do now is to offset and see if we can set a jump value. So let's do this. If button B, let's say entity.direction.y equals -5. It is jumping, but it's not jumping high enough. It's moving, but it's not moving the player with it. And all right, we'll take a look at that later. What I want to do is get this at the right area. What I'm just kind of confused about is why the test position isn't the correct area. All right, so let's do this. What we're going to do is I really believe that this direction should be velocity. So I'm going to change direction to velocity. Let's just make sure we don't break anything. All right, so now what I just want to make sure is that the that little green square is actually testing at the right place. Now, I'm just looking at the other code to see what I'm missing here for why jumping isn't working. So what we're going to do here is else entity standing equals true. What we need to do is we need to calculate the next position. So let's do this. Local next position equals new vector. And we're just going to, the only reason I'm defining it up here is we're going to reuse it each time. And what I want to actually check here is next position y equals, this will be the stand-in. This is what we're going to do. Next position y. This would be the same thing. Technically here it would be next position x would equal rect x plus entity velocity x. And since we're not doing anything with that, he's just going to stay in one position. Now, right? Hold on. I need like an image of like how velocity moves. It's more detailed record of an airplane measure. Smaller the time interval. All right. Your notion of velocity is probably similar to the scientific definition. You know that a large displacement in a small amount of time means a large velocity, and that velocity as units of division in time, such as miles per hour, kilometers. Average velocity is defined by the change in position divided by the time of the travel. Oh my God, my brain is starting to hurt. I need to go back and like, I'll do that offline. I can just make sure that I'm actually applying the velocity correctly. Why did that end? Interesting. All right, so now what we want to do is the test position is going to equal, all right, here's what we want to do. Let's pull this out here. And we want to calculate the position to test for. So what we're technically going to test for is the bottom right-hand corner test for bottom of entity. And the reason we're doing the bottom right is that well, we'll change this actually. We're going to wait. No, we need to do this here. Each place that we test for velocity, we need to redo the collision. But what we got to do is entity rect x. This is wrong. All right, let's let's fix this real quick. We got to fix all this collision crap. It's a little sloppy. All right. So starting out, we're going to calculate the delay between frames as an int, right? Then we're going to accumulate gravity between each update by simply taking the entity's velocity and multiplying it by the delay, delay multiplied by gravity. Then we're going to get the current, here we're going to cat max minimum gravity value to 5. So we can't move any faster than 5 pixels per frame, right? And we're going to get the current entity's position. So now what we're going to do is calculate, or we're going to calculate the next position, right? And all we do here is we get the velocity y in this. As a to-do, need to calculate entity velocity x. All right, so there's that. Now, entity velocity y, if the y is greater than, if entity velocity y is greater than 0, we're going to take a look and figure out, we're going to calculate the test position. Now, regardless of whether we're moving to the right or the left, we always want to get the test y position. So let's calculate the test position x. All right, so we always look for the front. We look at the front of the entity. So what we're going to look for is equals, if entity flip h is true, we're going to use the entity rect x, or actually it's going to be both. We're going to use the entity rect x, and I'm just going to try to write this a little bit easier. Oops. All right, so we're always going to look at the front of the entity, starting from the left position. And then we're going to say if the entity is facing right, we need to add the width. So in this case, what we're going to do is take the test position x and do test position x equals test position x already plus entity rect hit rect x plus entity dot hit rect width. And again, what we're doing is we're making sure that we always want to start, if we look at this, is that still running? Numbers? If we look in our file for a second here, and like let's take this guy right here. So we're going to start right here at this pixel, which is the left-hand corner. It's probably... Let's do it this way, and we'll just sort of illustrate it. Right? So we're always going to start our test at this pixel. Now, if the player is moving forward, we want to basically move the rect over and then add its width. So let's take a look now. So here, what we're doing is we're taking the test position X. So if entity flip H equals false, then end. If the entity is facing right, we need to add the hit, rect, offset X, and width. All right, so now I'm going to get rid of this test position X. And there's all kinds of ways that we calculate this stuff, right? But what we're really looking for is, you can see the green area is now to the right. Now, we could always get like half of the player's width. Like there's a few different ways that we can do it, but we want to make sure that right now that green area is like that. The green little dots on the far right. We'll fix the height in a second. Like if I was to get rid of this line, we would basically be testing all the collision on the left-hand side of the player. And that's wrong. In fact, what we should do is we need to take into account the rect X. Good thing I did that to test it out. Like take a look right now. Now you see that we're always, so that's, if the player was left here, we can fix it right here and test it. If the player is facing left, we're going to test the left side of the area. If the player is facing right, we're going to test the right side. What we should do is, just for consistency, we should probably just subtract 1 from it, just to make sure that it's within the actual collision area. If it's false, it's automatically there. Oops, I mean if it's true. There you go. All right, so now we just got to fix the height. So it is technically working correctly. It's just we're not taking into account the correct thing. So here's what we're going to do. If the velocity y, if velocity is greater than 0, meaning that it's falling down, what we're going to do is we can get rid of this. What we want to do is we're going to take the test y position is going to equal this plus the velocity x. So we're going to take the x. So we're going to start by taking the test position y. I'm just going to hide this for a second. The test position y is going to equal the next position y plus the entity dot hit rect y plus entity dot hit rect dot height. Right? In essence, what we're doing is we're saying, all right, so let's look for what the next position is, and then move that. We don't need. Yeah, we then move it by the offset of the hit rect and then the actual hit rect itself. Height. Why is test position y now so far off? Test position x, test position y. Next position y. Next position y. Why did it move out so much? I'm really confused because the height shouldn't be an issue. Why is it moving it out like that? It's like adding that to the X value. I'm really confused as to why that green box, that green little pixel is. Why is it offset so much? Why is it set to 0? Why is 0, 0 there? That's 0, 0. So let's set the test position Y. Right, test position Y, rect Y plus the rect height. Why is the test position X so big? It's the next position plus the, here we go, hit rect X. That was the problem. All right, so now next position X plus the hit rect X. There we go. Then we increase it by the width, right? Let's see if we're back to the right position. There we go. Back to the right position. If we set this to true, we're looking, if you're just tuning in, I'm just working on some basic physics stuff, and then we're trying to get that green box into the right location. That little green pixel is what I'm testing, where the collision box is. I'm just making sure that everything is right. So technically it looks like collision is working, but because it's not where I'm expecting it to be, I'm a little concerned that something is screwed up. So let's get rid of this. So let's calculate the position to test for the bottom of the entity. So we're going to take the next position plus the hit rect plus the hit rect height. Looks like it's off by 2. What if we just did 24? All right, minus 1. So basically what's happening is, let's take a picture of this and open it up in Photoshop, and you'll sort of see what's going on with the collision. There's 2 ways we can do the collision. We can either seal it or we can floor it. And what's happening is when it moves to the next pixel, the next thing you see right here, so there's this gap. This gap is the height in the, here we go. So this height, basically what we want to do is take the entity height minus the entity.hitRect.y minus 1. Actually, we'll leave it like this and see if this works. This should fix it. Or plus 1. So that fixed the collision. Let's make this floor. Nope, seal. I want to move it ahead. All right, I don't know why that green pixel is down. If I remove, the only thing I think of for debugging it is if like that's where it is right now. So why would I need to? I'm just confused for a second. I'm just going to walk through this real quick, step by step, and to see what we're doing. We're taking the next position, Y, which should be the top of the current player, and we're going to add the rect height to it, right? Which is that. So right there, the collision stuff is correct, -1. But it's not taking into account the actual... It's not taking into account the difference in the height of the... If I floor this, does that fix? There we go. That's what I'm looking for. Sounds like really weird. Why? I just want to do entity rect x and entity rect y. I just want to see where the real x and y value is. The entity's x and y values. So the top left corner is where we're starting to test. What is the engine you're using for this? The engine I'm using is called Pixelvision 8. It's a fantasy game console that I wrote, and this is one of the tools to actually build games with it, called the Game Creator Pro. Let's see. So... all right, I think this is as good as we're gonna get, right? Like the only other thing we could do here for this rect would be if we were to add the entity hit rect y value, would move it, whoops, minus, sorry, plus, and then it would be plus entity rect hit rect y. Why does that have to be minus? What is going on here? What is the hit rect y value? Something is wrong. I create the player. -5. This is the problem right here. I don't like the way I do this rectangle stuff. This should be 5 in, 5 down. Like, this should be the value right here. I gotta, there's a bug. There's a bug in the way that I set this up. We're gonna configure this. We're gonna set this to 5, 5. And now, huh. All right, I don't know if I really feel like, I gotta actually stop. So we'll leave it as this. I'm gonna make a note for myself. All right, we'll see. I'll come back and I'll deal with this another day. Tomorrow I'm going to be streaming. Tomorrow I should be able to fix the whole physics engine and everything. So it shouldn't be too difficult to get this working. But long story short, right now everything seems to be working fine. What we'll do is, yeah, I have to, tomorrow I'm going to have to add in jumping and all that other jazz. So, all right. I think that's where we're going to end for the day. So thanks everyone for watching. I'm off to go see Infinity War today, which I'm actually very excited about. So, all right, I think this is good. This is good, and there's not much else we're going to do here. We won't save all this stuff, but we now have the basic foundation for the physics engine. So all right, everyone, thanks for watching, and I'll be streaming almost all of tomorrow. Well, at least until like 1 tomorrow. So from 9 a.m. to 1, I'll be streaming. So if you can, tune in, and I'll see you guys tomorrow. So I just saw your question real quick. What language do you use for the engine? So for Pixelvision 8, you can either use. So here, I'll open it up. If you go, so if you go to pixelvision8.com, it walks you through. There are 2 versions. There's basically, I keep saying the word basically over and over again. The Game Creator Pro allows you to. Oh, I don't want to see it on the dashboard. I want to see it as a. Let me log out. So the Game Creator Pro is a tool that gives you everything you need in order to build. I don't have any pictures. I should actually add some pictures. It's basically a self-contained little development environment and uses Lua. If you go to Pixelvision 8, Pixelvision SDK, there is a C# version, and you can run it inside of Unity and just use C#. So the Game Creator, which is what I use for testing everything out, is written on top of the open source engine, and it just allows you to. It's more. Think of it more like a sketch pad for coming up with 8-bit games. But if you really wanted to build something more serious and still have the same constraints as a fantasy game console, I would say use the C# version. And if you get the Pro version or you subscribe to the Indie membership, which is $1 a month, you get access to inside of if you view the content. Oops, I don't want to buy this right now. No, cancel. When you get a copy of the Pro version, you wind up getting a PV8 runner, which allows you to. It's a Unity package, so you can basically bring your Lua games over into Unity. So cool. All right, I have to go. Thanks again, everyone, and I'll see you guys tomorrow.